So in the last class, we have gone through like what actually fact and dimensions. So basically, we discussed that fact is a numerical value and which impacts on the business, and dimensions, dimensions are nothing but which gives context to the fact. Okay, and in general, there are cases where, yes, as I say, I showed actually in the Tableau perspective as well, right? So in Tableau, we do have dimensions and measures, and we are going to use to create any of the visualizations, right? So we are going to use dimensions and measures. Let me showcase that quickly. But anyhow, for data modeling, I have to use a Tableau for understanding these relationship between the tables. Okay. So data modeling classes, topic is very important. So in general, like understanding the relationship between the tables, right? So which is very, very important. So let me showcase that. But basically, we have a concept called as dimensions and facts. And as I said, we have dimensions. These are dimensions, right? So when you drag anything, this will give you the naming convention, right? Above the line, all are dimensions. These are all dimensions. And below all are measures, like sales, quantity, profit, discount. This one, sales, quantity, profit, discount. Example, we have a salary, account balance, marks, correct? And we discussed a few more things like we actually called as measures in Tableau, and as I said, KPIs, key performance indicator, correct? So we do have not all the measures as KPIs, but basically there are a few important KPIs. Okay, all the important measures is called as key performance indicator. Okay. So dimensions, importantly, we have this ID columns and description columns. In general, I'll showcase the advantage of ID columns. That is what we are going to discuss in detail in the data modeling topics. Okay, so dimensions, which gives context to the fact, and we do have importantly a fact table and dimension table. Okay, so we have fact table and dimension tables. So in the fact table, let me showcase an example. Okay, this is a proper example for understanding the snowflake schema. But before moving on to that, this is a proper example for understanding the like dimension table and the fact table. So dimension table consists of only dimensions. Okay, in dimension table, so we do have only dimensions. In fact table, we have both facts and dimensions. Understand, right? So let me showcase that example. Let's say you can consider any of the dimension table, but when you look into the table names, right? Let's say LU underscore brand, LU underscore category. So LU is like dimension table to differentiate the naming convent, and I mean dimension fact table. They have given this LU. LU is a dimension table. Okay. So if you want to consider brand, let's pull brand here. So we have different brand IDs and brand names, correct? So we have brand ID and brand names. Understand, right? It's just an example. So let's say you can see Sony, Xerox, Microsoft, Hitachi, and Panasonic panel. Okay. So we do have brand ID and brand name. This is just a simple table. But in general, we may have multiple. I mean, this is Snowflake schema table example. I'll showcase the difference between Snowflake and star schema. Okay. And there is one more, or I'll tell you one more example. Okay. But to get brand information, I mean, to get some other sales information, so we have to check whether we have this brand ID in the fact table or not, right? But when you look into this, we don't have a brand ID directly in the fact table. We have day center sales, customer sales. This is city subcategory sales, right? Item month sales. So we have item level data, and we do have category level as well. So that is what this is the proper example for Snowflake schema. But let me give you, you understand, right? So in the dimension table, we do have only dimension. Okay. In the fact table, but this is just an example. In the fact table, let's consider day center sales is a fact table. So in the fact table, we do have facts, and you can see we have facts and key columns. So can you tell me what are all, as I said, in the fact table, we have facts and dimensions. Can you tell me what are all the columns as dimensions and what columns are of, I mean, facts?
So, okay.
No, just go ahead. Anything is fine. Yeah. Multiple answers is also fine. Yeah.
The total cost is a fact, numerical value, the total cost.
Okay. Total cost is a fact. Perfect.
Daytime is a dimensional dimension.
Date is a dimension. Okay.
And total cost fact.
Total cost is fact. So you can tell in an order, like.
What was your question, Amish?
No, my question is, which one is called as dimension? Which column is called as dimension? Which column is called as fact? So let's say you said date is a dimension, total cost is a fact, right? That's true.
Mm-hmm.
So I just want to know what, like,
So
all
of it are facts except the dates is dimension.
Okay, perfect.
How about call whatever ID? It should be dimension.
Yeah, that's good. That's what I'm expecting. So basically we have day date and call center ID. Okay.
Mm-hmm.
Day date and call center ID or dimensions. Total dollar sales, total unit sales, total cost, and gross dollar sales is a fact. Okay. Clear all? Understand, right?
So they call
Call center
center
ID.
ID
Yes, as I said, right, there are, as I said, we have facts and dimension,
Oh, okay.
right? And every numerical, this is the statement we discussed, right? Every numerical
Yeah,
value is not a fact.
it's a fact.
So
Yeah.
when you look into this data, this is a number, right? And we are considering this as a call center ID, something like customer ID, something like employee ID. So we are considering this is a unique identification number. Okay.
Mm,
So in that case, we do consider it as a dimension, so not a fact. Correct.
mm,
So as I
yeah.
said here, customer ID is a dimension, employee ID is a dimension, even like account number, day or day date. That's what we discussed, right? Day underscore date or day column is a dimension.
Mm,
Correct. So any of the ID columns, you can remember that any of the ID columns which considered as a dimension. Okay. Clear, right? So this is an example of a fact and I mean fact table and dimension table. So dimension table consists of only dimensions. Fact table have both facts and dimensions, but I'll give you an example. Why do we maintain dimensions in the fact table? Okay, let's consider a very simple example. Let's understand here. Okay, let's say I have employee table, and in that employee table we have employee ID, employee name, and I have a salary table, and I do have salary. This is one single table, and this is one table. Now I have this is just an example, sample data, 101, 102, 103, and employee John, Adam, and some ABC. So can we get employee wise? I want to fetch employee wise salary. Okay. Whether it is an employee ID wise or employee name, but generally we have to display employee name, correct? So if I want to get employee wise, if I want to see employee wise salary between these two tables, right? I have employee information in the employee table and the salary information in the salary table. So can we get accurate data by using these two tables?
Hamish, can you
Yeah.
repeat your question again?
We'll select using the select statement.
Okay, so my question is, let's understand, okay? The question is, there are two tables, which is salary table and employee table. So I want to know the employee by salary. I want to write a SQL statement, okay? SQL statement to get SQL statement for employee by salary. So just try to understand the basic SQL as well, okay? I'll showcase. That's a power, like we have advantage in Tableau as well. I'll showcase that.
Okay, so maybe we need a date and
We need a
the date. We can use them.
Employee wise. I need employee name.
Oh, okay. Employee name, employee ID, and the salary.
No, I don't require employee ID to display. I just want to know the employees employees names, and okay, let's say John and Adam and ABC, and I want to know the proper salary here. What is John's salary and what is Adam's salary, and what is ABC salary?
So your question is like you want us to like tell you what would be this
Equals the basic, yeah, or you don't require any answer, okay, like the solution for the SQL statement. But I'm just asking, is that possible to, with this table structure, can we achieve the results? That is what my question.
Oh, I see what you mean. I mean, um, I mean, for me, they should have something in common so that we can share information. Like if the salary has like another table, like employee ID, then we can.
Perfect. That's a very good answer. Yeah.
Okay.
Anyhow, I'm going to discuss in detail. Okay. This is just an example, as I said. So now we should have a common column between the tables so that we are going to get proper data. Even we can, I'm going to showcase how to write the SQL, but let's try to understand the importance of any of the, if we can maintain ID columns, we can also use description columns. Even we can use employee name to, establish the relationship between the tables. Not only employee ID, even we have department IDs as well. Okay, there are different columns. So let's say I have 102, 101, and 103. So can you tell me what is John's salary?
1,000.
Yeah, 1,000. Yep.
No, just look into the data and tell me.
Oh, no, 2,000. Sorry.
Yeah. So John, what is the ID?
It's 101.
101.
So this is 102. This is 102.
Yeah.
So this is 2000. Now Adam's salary, it's 102, and this is 102, which is 1000. And 3000. I know this is simple, but I mean, let's say if someone doesn't have any of the like SQL or a basic SQL knowledge, so that helps for sure for them. So, but anyhow, as I said, I'm going to discuss in detail. That is the reason why I have given the statements. ID columns helps for establishing relationships. Okay, I'll write a basic SQL, like that is what the select statement select. So generally in the select statements, we have to use columns. Okay, what are all the columns we have to fetch from the table name? Okay, select employee name, comma, salary. Okay, from employee table, comma, salary table, where employee table we can use as an alias name. Okay, every time if you don't want to repeat employee table, I will tell that as the employee in employee table as ET, salary table as ST, which is an alias name. Okay, short name, where ET dot employee table dot, what is the common column between these two tables?
Employee ID.
Employee ID. So that is very important. Okay, employee table dot, that is what I'm going to discuss in the next class, which is next topic. Employee ID equal to salary table dot employee ID. So this is what, this will drive you to get proper data. This join employee table dot employee ID. Okay, employee table dot employee ID equal to salary table dot employee ID. So that we are getting, it's not like for John, it's not 1000. John, it is 2000 because of the proper joins. You can see 101 here and here 101. Based on this, we are getting proper data. Without a proper relationship, we don't get proper data. We will get the results, but we don't get proper data, which is not recommended. Okay, so importantly, we have data modeling concepts, which is star schema and snowflake schema. Anyhow, I'll take some better time to understand this for you, and I'll compare the same thing in Tableau as well. Okay, so let's understand what actually star schema. Star schema is nothing but if a fact table generally surrounded by multiple dimension tables. A fact table is surrounded by multiple dimension tables, and we have direct joins between fact table and dimension table is called star schema. Okay. A fact table is surrounded by multiple dimension tables, and we should have a direct joins between fact table and dimension table is called as star schema. So we'll discuss snowflake schema in the next class, but I'll give you more details about star schema. Okay.
Okay.
Let's say an example of fact table. A fact table, and we may have in the fact table we have like sales, profit, discount, quantity. There are few dimension tables, important dimension tables, as I showed in the last class. Important dimension like customer information, geographical data, product information, and the time hierarchy, right? I'll use only these information. Let's for better understanding, because most of the projects will have all these tables actually, like the customer table and the time dimension. Let's say we have a time dimension table which have year, quarter. We have like month ID, month name. Okay, but I'll use all these naming conventions. Okay? Or I'll use day ID for understanding. And let's say I have a geographical dimension table, country, region, region ID, region underscore name. These are not required, but for understanding, I'm just mentioning here. Okay. State ID. But let me use only state and city ID, city name. Let's say we have some product information. Okay. Product dimension table. We have product underscore ID, product underscore name, subcategory. And we have some customer information, customer dimension table, customer underscore ID, customer underscore name, customer underscore address, customer underscore phone number. So this is just an example. Okay. We have a fact table and we do have 4 dimension tables. Okay. These are dimension tables. As I said, I will discuss practically. We have a star schema database structure. We have a star schema and even we have Snowflake schema. Not exactly star schema we connected. The orders table, which is not the exact example for star schema, but I'll showcase one more database. Let me connect to Microsoft Access database. There's a coffee chain query, which is a perfect example for star schema. And I showed the tutorial data, right? This is a proper example for Snowflake schema. So I'll showcase practically in Tableau, okay? So what is the concept here? A fact table. This is a fact table. It's just a terminology, okay, or just a definition, like surrounded by multiple dimension tables. But what is the important point here is the importance of star schema is we should have, okay. Let me use. We should have direct joins between fact table and dimension table. Understand, right? We should have direct joins between fact table and dimension table. Remember that we are into reporting and we don't create any columns, but I just left blank, okay? So most of the cases, right, they will use the lowest level of granularity, okay? So to establish relationship between fact table and dimension table, so here we have, let's consider day ID as a common key column, okay? So I'm going to use day ID, but we don't copy paste or something like that, okay? Remember, so we already have dimensions in the fact table, and based on that, we are going to establish relationship between these two tables in Tableau. I'll clearly showcase that, okay? You don't worry. And I'm using city ID, product ID, and customer ID. So we have already tables. Already we do have tables in the database. And on top of that, we are going to establish relationship between the tables, okay? So product ID and customer ID as the relationship. So this is one fact table, okay? And we have 4 dimension tables. And we do have relationship between the tables because of these ID columns, correct? Day ID, and here is also the day ID. Clear all? So we have relationship between these two tables, right? What is the common column between time dimension table and fact table?
Day ID.
Day ID. Let me quickly give you an example in Tableau, okay? So we have a fact table, we have location table, and we have product table. Let me draw fact table first. And what are all the columns we have in the fact table? Let's verify. We have a lot of facts actually. Let me showcase the fact table. We have a lot of facts. But let's try to understand few set of columns. So we have area code. Is it a dimension or fact?
Yep.
But
Area code is a fact or dimension?
Dimension.
it doesn't change. It's a fact, isn't it?
in that, if it doesn't change in general, like we have to strongly agree that it's a dimension. I mean, measures will aggregate and keeps on changing. But basically, yeah, I understand. But area code is something like a postal code or something like, like for mobile, I saw for mobile numbers, there is a 919, 615. Those are the area codes, right? So which is
Yeah.
the dimension, right?
Okay.
Date, right? Date. What is the date column?
Dimension.
Dimension. Product ID.
Dimension.
Dimension. And everything is, you can see different naming conventions of facts. Everything is a fact. Budget costs is a fact. Budget margin, budget profit, budget sales, COGS, inventory margin, marketing, and we have profit, sales, and total expenses. These are all facts. So what are all the dimensions we have? Area code, date column, and product ID. Perfect.
Okay.
Okay, these are the dimensions in
Dimensions.
the
Okay.
fact table. Right. Now we have a location table. Let me showcase the location table. And okay, do you remember what are all the, okay, let me copy this. Let me take a screenshot so that you'll get a better idea of the data. Even we have a, you don't worry about the data, but let me copy this date with data as well. Even we can also get only the column names. Okay, I'll showcase that. But this is the example for fact table. This is a very simple example for fact table. So we have area code, date, product ID, or dimensions. Not highlighting other facts. Okay. I'll share this file. And I'll tell you how to access these recordings tomorrow. I'm almost done. And even I will update with this today's class video as well. Okay.
Okay.
Okay. Let's remember what are all the columns we have. Okay. Let's highlight. So what are all the dimensions we have? Area code, date,
Date and product ID.
Now, if I wants to see some market wise, some sales information, some market wise or state wise sales information, right? Do we have any common column between fact table and location table?
Yep.
What is the common column between fact table and location table?
Area code.
Clear all?
Okay. Yeah. Area code.
I hope you understand, but still I'm just copying this. So this is the dimension table and this is the fact table. Okay. What is the common column between these two? Area code, right?
Area code.
One of the advantage in Tableau, that is what I'm going to showcase. So I dropped fact table, double click. Okay. I'll tell you why we need to double click and all these points. Double click. So we have a fact table, correct? In the fact table, there are 3 dimensions: area code, date, and product ID. And in the location table, there are other columns. Whenever you are going to drag and drop location table here, okay, let's see what is the common column we are going to get as a join. So we are getting join, okay, but we need to understand what is a common column, right? We need to understand what is a common column. So you know what is a common column between fact table and location table? I'm asking again, what is the common column?
The area code.
Area code, right? only one column we have area code. Okay. If you have only one column as a common key column, Tableau identifies, anyhow, Tableau identifies with a common naming convention, but you can see you're getting a join between these two tables by making use of area code. Area code from fact table and area code from location table. Clear all?
Mhm.
I hope you understand this, but yeah. So what is a common column between fact table and a dimension table? This is a fact
The
table.
area code.
Location table, the common column is area code.
Area code.
So my intention is I want to create a report on top of state-wise sales. So now I use area code as a join. Now go back to sheet one, and you have this area code, but my intention is I want to create a report. State from location table. State is coming from location table, and I want to drop sales information. So now I can see we're able to see state-wise sales information. Perfect. We are getting proper data. Understand, right? Clear all? So that way we are going to establish relationship between the tables. So we have these like dimension tables, and we do have common columns between dimension table and a fact table. So the advantage of star schema is better performance. Star schema gives better performance. Okay, clear on? And how many joints we are able to see here? How many joints we are getting? In between these two, how many joints? One joint, right?
Okay.
You know, joints are very important. I'll showcase I'll showcase sample data, like what is inner join, what is left join, with some sample data. Okay, some employee data information. I'll create a sample Excel data. We'll discuss that in the tomorrow's class. But let's understand here. We have a fact table. We have 4 dimension tables. Okay, and here also the same. Let's say here we have 2 tables. How many joins we are getting? One join. Correct. So the logic is, if we have n number of tables, we will get n minus 1 joins. If we have n number of tables, we'll get n minus 1 joins. Clear all? Let me showcase that. But before moving on to this, you need more clarity on the SQL side, right? Okay, I'm going to showcase a very good example of how Tableau generate the SQL. And we have to know, right? We have to know how many number of joins in terms of SQL. We have a, when you connect to any of the databases, not to Excel, when you connect to any of the databases, even MS Access database, we have an advantage called as convert to custom SQL. Let's say we are not expertise into SQL, or at least we don't have a basic understanding of SQL. This helps a lot. Okay, let me convert into SQL. Probably we have a lot of columns, but let's understand what how Tableau is generating the SQL. Okay, Control C. Let me go back to Notepad ++ to understand in a better way of the SQL code. Now you can see I'm using Notepad ++. Okay, this helps a lot. In language settings, you have SQL. Okay, if you set SQL, you'll get highlighted these keywords. That way I'm using language SQL. Now you can see what are all the tables you have. Fact table, location table, correct? This is a fact table and this is a location table. But how many joins you are getting here? Inner join on fact table dot area code equal to location table dot area code. This is what the join, okay? Fact table dot area code equal to table name dot column name equal to table name dot column name. That is what I said, right? In general, in the last example, employee table dot employee ID equal to salary table dot employee ID. Similar to that, we have fact table dot area code equal to location table dot area code. This is a common column, correct? Clear all?
Yep.
So this is Tableau generated SQL. Even if you want to write a SQL in Tableau, yes, that is possible. So that is what I'm going to showcase. We have a new custom SQL. So we can also write a custom SQL query and we can fetch a simple data. So let me showcase that example tomorrow. But we have only two tables, right? But if you want to join fact table to product table, what is a, let me showcase product table first. Remember what are all the columns we have? Product, product type, product ID and type, correct? Product, product type, and we have product ID as well. Okay. This product ID. Anyhow, I'll share this Tableau workbook files. Okay. Now, when you look into this fact table and dimension table, do we have any common column between fact table and product dimension table?
Yep.
No, this is a fact table. This is a fact table. And this is the product table. Do we have any common between these two?
Yes.
We have product ID, right?
Yep.
Now let's check whether Tableau will allow same thing, same functionality. And I'm just dropping product table here. And how will identify how this will join with the fact table, or whether it is going to join with fact table or dimension table. Okay, let's see. So I'm getting a join between fact table and the product dimension table. What is the common column? Product ID. Perfect. Tableau does not identify the actual key column, but if you have a common naming convention, you'll get that particular column. Okay. But I'll tell you how this will work. And there are cases where we have to manually change the join, but I hope you understand this, right? It's easy, right? You can drag and drop the tables, but we have to figure it out whether we are getting proper joins or not. Perfect. So you're getting product ID as a common key column between fact table and product table. Got it right?
Yep.
So I'll take the screenshot of this joins. So the fact table is directly related with dimension table and product table. Okay. That is what star schema, correct? If a fact table is, if we have a direct joins between fact table and dimension table, we do call it as star schema. That is what the example I'm saying here, right? A fact table is surrounded is just at a like definition, but the important point is we should have direct joins between fact table and dimension table is called as star schema. You should have whatever the dimension tables, you should have a direct join between a fact table and a dimension table. Clear all? Any questions on the star schema? Star schema is important for Tableau, but Snowflake schema, it is bit tricky, but you will get a lot of knowledge whenever we are working with Snowflake schema. Okay, we'll connect tomorrow. Please let me know whenever you're available. I mean, in the group, so that we can plan. But as I said, Snowflake schema is a bit important for understanding and I'll tell you what actually primary key, foreign key, and unique keys. Okay, what is the difference between primary key and foreign key? So today I didn't get any chance, but tomorrow I'll tell you why do we go for only ID columns, right? Why can't we use month name and month name as a common key column? I'll explain all the possibilities and better solutions, okay? And you'll understand why do we go for relationship between the tables and what is the importance of relationship between the tables. If we don't establish a proper relationship, right, we don't get proper data. So that is what we can see in practical. Okay.
Okay.
All right.
Oh, stop. Oh, wow.